electron over here, and this double bond now opens up. Remember, it cannot have more than 4 bonds for carbon. So let's draw that again. So if I have an O here and a pi bond here, so I can move this electron here to make a double bond, and this goes back to oxygen. So oxygen would have 7 electrons and would be negative. There's a new pi bond here, and this oxygen here now lost that electron. It has only 5 electrons, would be positive. So we're going to do some examples of that to make it clear what category this is. So this category is lone pair of electrons next to a pi bond. The other one is a pair of electrons next to a positive charge. Next to a positive charge. Which we call, when we're learning, it's a carbocation. So again, if you want to redraw that, let's say we have oxygen here. The oxygen has those 2 pair of electrons, and the H is missing here, so this is a carbocation, positive. So we can draw again an electron from here to make a double bond, and the new molecule we're going to see as a resonance structure, like kind on the top. So we are still going to have a double bond here. Oxygen is positive, but there's no charge here, because remember, we have a positive, we have a positive. In the case on the top, this doesn't have any charge, and the resonance structure we made, even though we have a plus and a minus, they cancel each other. So there's no net charge on this. So one of the things we're learning here, the charge, we have to make sure the charge is the same. And we also learned that we're only moving electrons as electrons or pi bond, which again are electrons. So you always look at the electrons and pi bond. We don't move hydrogen, we don't move carbon, none of those. The third category that Dr. Klein is asking us to look at is a pi bond, which is again electron next to a positive, which means the electron is missing. So again, if I redraw that, so we have a pi bond here, we have a positive here. That means there is only one hydrogen. And remember the other corners, we have 2 hydrogen here, 1 hydrogen here, 2 hydrogen. And this is the way we show the Lewis structure. We don't show the hydrogen, but we are showing the corners. So again, we have a pi bond here. So this pi bond on, and there's 1 hydrogen here and 1 hydrogen here. So if this pi bond moves over here, so the new structure, or the resonance structure, the pi bond basically is going to be moving here. And again, if you put the hydrogen there to learn, so this corner now, which was positive, now there is no charge. So there's no charge here. But this becomes positive. This becomes positive. So again, this is a resonance structure. If you have a pi bond, we have a pi bond next to a carbocation. The next one we're going to look at, and he's asking us to look at it, is a pi bond between 2 different compounds, elements. So if I look at this one, again, oxygen, double bond O. So we can see that we can move this pi bond and move the electrons from carbon oxygen back to the oxygen. So what we're going to make basically is a carbon positive and an O negative. So O is negative, this is positive, and this oxygen has the 2 electrons. I'm sorry, 4 electrons. But we're not touching these oxygen. We're only looking at this pi bond between the oxygen and the carbon. We're only moving the electron from the pi bond. The other one that is very common we learned in general chemistry, like is benzene group. So we can move the electrons sort of around, even though it doesn't go around. But electrons, instead of being between these 2 carbon, now between these 2 carbon, these 2 carbon, and these carbon.